Alright, in this next part, we're going to focus on evaluating logs. So when we evaluate logs, sometimes we might be looking for exponents, or sometimes we're just looking for the missing answer. So let's take a look at what we have in example 1. So it asks you to evaluate log base 2 of 32. And notice how we don't have the parenthesis like on the previous examples, which is okay. So if you prefer, you could add in the parenthesis to separate that this is a base of 2 and then this is just 32. So what we're going to do first is we're going to rewrite it. So log base 2, and then say you want to do parenthesis, which is okay, parenthesis 32 equal to x. So basically I added in the equal to x. We're basically looking for what exponent for the 2. So 2 to what power will equal to 32? So the only logical assumption that we could go to is based on the numbers I have given to you in the previous chapter, in the previous section, with the second powers to the third powers to the fourth power and to the fifth power, including the sixth power. So in the notes that you have written down, which I would recommend that you go back to, 2 to the fifth power is 32. So my answer is x equals 5. That's the exponent, 2 to the fifth power. If I write right here, 2 to the fifth power is 32. That's what I'm asking for. So x equals 5. So again, I recommend that you go back to the numbers that I have given to you from the previous chapter, from the previous section, where I list out the numbers with the second power, the third power, the fourth, the fifth, and the sixth, because you're going to be looking for either the exponent or the answer based on the problem that you have here. In this example, we have log base 3 of 81. So let's rewrite that. So log base 3 of 81, and I'm going to put in my equal x. So we're basically asking 3 to what power equals to 81. And the only thing that we can think of is 3 to the fourth power will equal to 81. So x equal to 4. Because if you were to rewrite it, 3 to the fourth power equals to 81, that's true. So therefore, x equals to 81. And then here's my final answer. In this example, we have log base 5 of 125. So let me rewrite this as log base 5 in parentheses 1 over 25, excuse me, 1 over 125 equal to x. So we're basically looking for an exponent for 5 that will equal to 1 over 25. So the thing is, when we try to convert a base into a fraction, that means that it has to be a negative exponent. And then how we change 5 into 125, if we look at the numbers I have given out from the previous chapter's section, 5 to the third power will be 125. So I'm going to put 3 here. X equals negative to the third power. So over here, if I rewrite it, 5 to the third is 125. But when it's at 5 to the negative third, it will be a fraction, 1 over 125. So which is correct. So my final answer is x equals negative 3. So in this example, since we have a fraction in our log problem, so that means you have to think the base to what power. So for the base of 5, to what power would it make it into a fraction, 1 over 125? So for sure, when you see a fraction, then you can say that the exponent or the value of x has to be negative. Has to be negative. And then from there, you just look at to what power to get 5 into 125, which is in the denominator, which is 3. So my final answer is x equals -3.